So I was telling you that change in height by change in time, delta is to be read as change. Delta H means change in height, delta T means change in time. This is only giving you average growth rate, or you can say average rate of change of height, or to be more precise, average rate of change of height with respect to time. WRT is my shortcut for with respect to. Okay, or you can say it is average speed with which height is changing with respect to time, which height is changing. Okay, on the other hand, if I put that denominator, which is the change in time, to 0, that means time is not changing. If I do that, so if I write delta H by delta T with limit delta T tending to 0, this quantity now becomes growth rate. Exactly, no average here, growth rate of height with respect to time. Generally in physics, the denominator will be time always in physics. In mathematics it could be something else, we will see that, but in physics the denominator will be time. We will talk more about this soon, it will follow. So it is growth rate of height with respect to time, or you can say rate of change of height, you can say, and you can just stop there, because in physics rate of change means with respect to time, or to be more precise, you can say rate of change of height with respect to time, or you can say speed of change of height with respect to time, speed of change of height with respect to time. Okay, all these mean the same thing, all these are meaning the same thing. Okay, now whenever any quantity is tending to 0, for example here in the equation that I have written, the denominator delta T is tending to 0. Whenever it is tending to 0, whenever any quantity is tending to 0, that quantity is called infinitesimal. Okay, so I will write in the next page, delta T, this is simply change in time. If delta T tends to 0, it is infinitesimal, meaning infinitely small, very small, tending to 0, meaning infinitely small. Then when it is tending to 0, when it is infinitesimal, you can write it as dt. Instead of delta T, you can write it as dt, provided it is tending to 0. Okay, you cannot write delta T as dt if the change is very big, but if the change is very small, tending to 0, you can write it as dt. So delta T can be written as dt if delta T tends to 0. So to put it in this way, if delta T tends to 0, it can be written as dt. That's the meaning of dt. So dt means very small change in time tending to 0. So whenever you see quantities like dx, okay, dx, dy, dt, dz, all these quantities are infinitesimals. Infinitesimal means infinitely small. Okay, infinite is different, infinitesimal is different, both are opposite. Infinite means very big, infinity is very big, infinitesimal is very small, tending to 0. Okay, now coming back to our definition, so rate of change of height, we wrote it as rate of change of height. If you remember, we wrote it as limit delta T tends to 0. Without the limit, please note it is only average rate of change in height by change in time. Now because delta t is tending to 0, the denominator we can replace it with dt. Just now I told you when something tends to 0, some variable tends to 0, you can write d of that variable. So if delta t tends to 0, you can write it as dt. If delta y tends to 0, change in y tends to 0, you can write it as dy. Okay, so denominator is dt, but numerator I am writing as dh. Why? Why the hell is numerator also written as dh? Nowhere I mentioned that delta h tends to 0. Nowhere I mentioned delta h tends to 0, but it is implied. How it is implied? Because h depends on time. Please understand this. H depends on time. Height depends on time. H equal to t square. So if you take a small time interval, height change will also be very small. In a small time, height will change by small amount. In a big time, height will change by big amount. So the numerator is change in dependent variable. Dependent. H depends. So whenever you have an equation, you have two variables. One is independent variable, other is dependent variable. So h depends on time, h is dependent variable. So when independent variable change goes to 0, dependent variable change also will go to 0. It is implied. So you can write numerator also has dh. So rate of change of height is written as dh by dt. This is called growth rate of height, or growth rate of height with respect to time, or rate of change of height with respect to time, or speed with which height is changing with respect to time. Any term, any way you can say it doesn't matter. Okay, so it is written as dh by dt. So now if I go to mathematics, in mathematics generally you don't have height and time. In general, what do you have in mathematics? Y and x you have. So generally when you come to mathematical perspective, x will be the independent variable. Generally that's how it is taken. X is the independent variable. Y will be the dependent variable. Y depends on x. Depends on x. Suppose you have y equal to x square, some equation. Okay, I am not going into very complex terms in mathematics like function, what makes a function, what is one function, onto function. So much of complex things are there in mathematics. It's not my subject really. I am not a maths teacher, though I prepared for JEE mathematics. So Vishwanathan sir will be helping you in that. Maths teacher will be helping you. So y equal to x square is some equation where x is the independent variable. Depending on what x takes, y will take corresponding value, y will be the dependent variable. So if you don't know the relation, you simply write y equal to f of x. Y is some function of x. This, don't get confused with f of x. F of, this is read as, this term with brackets is read as f of. Whatever you write inside, that is x, f of x. So instead of f of x, you can say depends on. F of can be replaced with depends on. Simple, to make you understand it very clearly. Depends on. So y equal to f of x. Instead of saying in a complex way, I can say y depends on x, matter ends. Y depends on x. How? I don't know. It may be y equal to x square. It may be y equal to sin x. It may be y equal to x cube. I don't know. If I know, you will write it. Suppose y depends on x as x square. So y is f of x. You can write it as x square. If you know how it depends, you can write it. If you don't know how it depends, you simply write y equal to f of x. Y depends on x. That's it. You leave it. Okay. The height of the baby depends on food he takes. Okay, up to certain age, of course. It depends on the food. If he is not taking good food, his growth will be retarded. If he takes good food, so height depends on food. You can say that. Okay. So if you say food has some variable x, height has some variable h. H depends on x. You can say nothing like that. So f of x is nothing but depends on x. So in mathematics, you use the variables y and x. So y equal to f of x means y depends on x. So here x is the independent variable, and depending on what values it takes, y will depend on it. So y will take some value depending on what x takes. So y is the dependent variable. X is the independent variable. Y is the dependent variable. Okay, now whenever you have such a relation which is involving one dependent variable and one independent variable, okay, one dependent, one independent, then you can define rate of change of dependent, now I am taking you to higher level concept, rate of change of dependent variable with respect to independent variable you can define. Okay. So whenever you have two variables, one is independent and one is dependent, and you have a relation between them, then you can define rate of change of dependent variable, means how fast a dependent variable changes for a small change in independent variable. That is rate of change. How fast dependent variable changes for a small change in independent variable. So how do you define that? You define that as limit delta x tends to 0 delta y by delta x. This is called rate of change of dependent variable with respect to independent variable. Okay, always independent variable is in the denominator, change in independent variable, for example delta x, is in denominator, change in dependent variable is in numerator, and change in independent variable goes to 0 because it is not average rate of change, it is exactly rate of change. It is exactly rate of change. So whenever you have a dependent and independent variable, you can define rate of change. By default, rate of change means rate of change of dependent with respect to independent. Okay, rate of change of dependent with respect to independent. That is change in dependent divided by change in independent, with change in independent going to 0, tending to 0. If you want, you can write it as dy by dx. So this is rate of change of dependent with respect to independent, or rate of change of y with respect to x, okay, or growth rate of y with respect to x, you call it growth rate of y with respect to x, or now I am introducing the term which people use in mathematics, derivative of y with respect to x. So rate of change is also called derivative of y with respect to x, or some people call it differentiation of y with respect to x. So rate of change, growth rate, derivative, differentiation, all are same. Just to confuse you, people use different terms, they are all same. Okay, so when you have a relation between dependent and independent variable, you can always define rate of change of dependent with respect to independent. So it is how fast the dependent variable grows for a small change in independent variable. How fast is this growth rate? That's why we call it growth rate. Okay, we will later see geometrical meaning of this growth rate in more detail, but as of now, this is what you have to keep in mind. So if you remember, in the case of physics, instead of y we took height, which was dependent variable, instead of x we took time, and we knew the relation also, h equal to t square for our baby. Okay, so we defined rate of change of dependent height with respect to independent time. In physics, the independent variable is always the time. Independent variable always in physics, most of the cases at least, is time. In mathematics, it could be anything. You just say x and y is dependent, x is independent. Okay, so now so let me write the mathematical definition. Now. I'm just erasing all these slides to make it clear. Yeah. So suppose I have y equal to f of x. So here y is the dependent variable, x is the independent variable, y depends on x. How, I do not know. Somehow it depends, let us say. Now I want to find growth rate of y with respect to x, or derivative of y with respect to x, or rate of change of y with respect to x. So how do we define it? We write it as dy by dx, change in y by change in x, with the change in x going to 0. When change in x goes to 0, change in y also goes to 0, because y depends on x. Now this is written as limit delta x tends to 0 delta y by delta x. You write it like this. Okay. What is numerator? Change in dependent variable. What is denominator? Change in independent variable. Okay. Suppose independent variable was x and it changed to x plus delta. It changed by some amount. Then dependent variable will be f of x initially, and new value after x changes, it will be f of x plus delta. So when x value is x, y value is f of x. When x value is x plus delta, y value is f of x plus delta. Okay. When x is 0, y is f of 0. When x is 1, y is f of 1. If you exactly know what is the dependency, you can calculate it also. Okay, I don't know the dependency. I know it depends, but I don't know the exact dependency. Is it x square, x cube? I do not know. So I just say when x is 0, y is f of 0. When x is 1, y is f of 1. When x is x, y is f of x. When x is x plus delta, y is f of x plus delta. So you can write limit delta x change in x. X is changing from x to x plus delta. So what is change? Delta. Final value minus initial value. That change should go to 0. That change in x is in the denominator. What is in the numerator? Change in y. New value of y minus old value of y. Can you see that? So when x is x, y is f of x. Old value of x, old value of y. When x is x plus delta, new value of x, new value of y will be f of x plus delta. So you find change in y, you find change in x, okay, and divide and put change in x going to 0. So you get that. I'm sorry, I'll erase this. Yeah, so you get this. This definition, whatever you are seeing here, this is what is written in all mathematics textbooks as the definition of rate of change or differentiation or derivative. This is how it is written in mathematics. Okay. So once again, let me revise it. There are two variables here, x and y. X is the independent variable, y is the dependent variable. There is some relation between them. I do not know what is the relation. So I am just writing y equal to f of x. Y just depends on x. How? I don't know. Some function, some f of x. Okay. Once you have such a relation between dependent and independent variable, you can define growth rate of dependent with respect to independent. So here dependent is y, independent is x. So growth rate of y with respect to x, also written as dy by dx, is defined as change in y by change in x, and the denominator should go to 0. If it doesn't go to 0, it becomes average growth rate. But we want growth rate. So denominator must go to 0. So denominator is x, x change must go to 0. Suppose x is changing from original value x to new value x plus delta. Then y will change from f of x plus f of x to f of x plus delta. So change in y will be f of x plus delta minus f of x, by change in x will be x plus delta minus x, that is delta only, and change in x must go to 0. So delta must go to 0. So this is what is called fundamental principles, finding derivative or differentiation from fundamental principles. This is what is the basic definition in mathematics for derivative. Okay. Change in y by change in x, but they write in a complicated way like this: f of x plus delta means new value of y minus f of x, old value of y, by delta. Delta is change in x. So change in y by change in x. Change in x is going to 0, delta going to 0. Okay. So if you want in English language, I can write d of dependent variable by d of independent variable, derivative of y with by dy by dx we wrote na. Instead of y I wrote dependent variable. Instead of x I wrote independent variable. Is defined as change in dependent by change in independent variable, by change in independent with some limit. What is the limit? Limit change in dependent denominator, sorry, change in independent going to 0. So this is the definition of rate of change of dependent with respect to independent. You always find dependent variable rate of change with respect to independent. Okay. So is it clear what I am trying to say? So I'll just, so d of, I'll write dependent to make it clear, by d of independent. That means change in dependent by change in independent with change going to 0 is limit independent going to 0 change in dependent by change in independent. Okay. Change of, I'll write Change in is unnecessarily confusing. Change of dependent by change of independent, with change of independent going to 0. Okay, change of independent going to 0. So anyway, if you represent dependent with y and independent with x, so I am writing dy by dx. This is change in y by change in x, with change in x going to 0. In mathematics, the relation between y and x is taken as y equal to f of x. Then this becomes limit delta tends to 0, f of x plus delta minus f of x whole divided by delta. It becomes that. Okay, so we will for some time now move into mathematics and take this mathematical definition and try to do some calculations with this. So let's do that. So now I am almost coming to the crux of this topic, first part of calculus, called differentiation. Suppose my relation between y and x is a very simple one, y equal to x. Then I want to find growth rate of y with respect to x, dy by dx. What is it? Suppose y equal to x square. I want to find growth rate of y with respect to x. Different cases I am taking. In one case, y is x. That means the relation between dependent and independent variable is a very simple one. Dependent variable simply follows independent variable, y is x. In the second case, y is x square. In third case, y is x cube. Then I have to find rate of change of y with respect to x, or differentiation of y with respect to x, or growth rate of y with respect to x. Similarly, y equal to x power 4. I want to find dy by dx. And we will see from here what happens if y is x power n. What will be dy by dx? We'll try to generalize. We'll get our first formula now in differentiation, in rate of change. So first we'll take y equal to x. So I want to find dy by dx. That is change in y by change in x, with the change in x going to 0. So first you have to change x. So I change x value. From x to x plus delta. Then y value, but y is x only. So y value will also change from x to x plus delta, because y is same as x. So y also changes from x to x plus delta. So what is change in y? Final value minus initial value, delta, by what is change in x? Final minus initial, delta. With the denominator delta going to 0, you can cancel delta because it is not 0, it is only going to 0. So it will be 1. Okay? After cancelling, there is nothing to check, it is going to 1. This value is simply going to 1. As delta goes to 0, suppose delta is 0.1, 0.1 by 0.1 will be 1. Suppose delta is 0.01, 0.01 by 0.01 will be 1. So when y is x, dy by dx is 1, growth rate is 1. When y follows x, when y is equal to x, growth rate of y with respect to x, rate of change of y with respect to x will be 1. In physics, instead of y, you can have some velocity or height. Instead of x, you can have time in physics. So you write dh by dt. So if h is t, suppose there is a baby whose height is changing with time in a simple way like this, then growth rate of the baby is 1. That means 1 meter per second. It's going by 1 meter every second. It's growing by 1 meter every second. Simple. That's the meaning of this statement. So when y is x, dy by dx is 1. What if y is x square? Then dy by dx, we call it derivative of y with respect to x, or growth rate of y with respect to x, or rate of change of y with respect to x, is change in y by change in x. First of all, you should change x. X change from its original value x to x plus delta. Then y will change from x square, because when you substitute x only you get y. Y is x square, to x plus delta whole square. Can you see that? If x is 0, y is 0 square. If x is 1, y is 1 square. If x is x, y is x square. If x is x plus delta, y is x plus delta whole square. Okay? So this is giving you change in x. This is giving you change in y. So what you have to do? Change in y by change in x. What is change in x? X plus delta minus x, that is delta. And you must put that change in x to 0. So we have to calculate this. Let's simplify. Limit delta tends to 0. Numerator, you apply a plus b into a minus b. 2x plus delta into a minus b is delta by delta. Since delta is only going to 0, you can cancel. It's not exactly 0. So this value will go to 2x. So when y is x square, dy by dx or growth rate of y with respect to x is 2x. Okay, when y is x square, growth rate of y with respect to x is x square. When y is x cube, let us check what is growth rate of y with respect to x or rate of change of y with respect to x. X plus delta whole cube, new value of y, minus x cube, old value of y, by x plus delta new value of x minus x old value of x. Denominator in fact is change in x, that is delta only. And that change in x or delta should go to 0. So limit delta tends to 0, x plus delta whole cube minus x cube by delta. Expand numerator. A cube minus b cube format is there. A cube minus b cube format. So a minus b gives you delta into a square plus ab plus b square by delta. Since delta is not 0, it is only going to 0, you can cut it. Where will this value go ultimately? If delta goes to 0, this value will go to x square plus, put delta 0 now. It's not 0, but very small value. It will go to 3x square. Can you see that? If delta is going to 0, this will go to x square plus x square plus x square, 3x square. Because when delta is going to 0, this goes to x square. This will also go to x square. This is already x square. So sum will be 3x square. So if y is x cube, so I'll write if y is x, then dy by dx is 1. But for clarity, I'll write it as 1 into x power 0 for clarity. X power 0 is 1 only. When y is x square, dy by dx is 2x. For clarity, I write 2x power 1. When y is x cube, dy by dx is 3x square. That's what we got just now. 3x square. So I can go like this. When y is x power 4, dy by dx is 4x cube. Rate of change of y with respect to x. So I can generalize when y is x power n, n being a natural number, dy by dx is n x power n minus 1. In fact, this formula is applicable for all powers of n which are rational. Any rational power of x. That means if n is rational number, this works. I am not going to give the proofs and all. You will learn in mathematics. So when n is rational, it works. So if y is x power n and n is rational number, what is a rational number which can be expressed as p by q? Irrational, it will not work. And n is any rational number, rational integer, it could be integer negative also. Then dy by dx is n into x power n minus 1. This is our first formula in this topic, in derivatives, in rate of change. For example, instead of y you can have h, instead of x you can have t, is n t power n minus 1 provided h is t power n. If the relation between height and time is t power n, dh by dt, rate of change will be n t power n minus 1, first formula. For example, if h is t cube, dh by dt will be 3t square. Power comes down and it gets reduced by 1. Okay, power comes down. See, if y is x power n, what will be rate of change? Power comes down, n comes down, and the new power will be less by 1. So if h is t cube, dh by dt will be 3t square. If h is t power 5, dh by dt will be 5t power 4. If h is 1 by t, you can write it as t power minus 1. dh by dt will be minus 1 t power minus 2. You can write like that. It works. As long as the power is rational, it works. If h is t power root 2, I can't do anything. Sorry. As far as I know, you can't do this. Okay, so that's how rate of change or derivative is calculated. So derivative is calculated when there are two variables. One is dependent, one is independent. You always calculate derivative of dependent with respect to independent. Okay, growth rate of dependent with respect to independent. Okay, and that is change in dependent divided by change in independent, with the denominator change in independent going to 0. The denominator must go to 0. That's how you do it. So this is the idea. Now in a similar manner, you can calculate derivatives for different cases, rate of change for different cases. What are the different cases? For example, if y is sin x, what will be dy by dx? Dy by dx. It will be cos x. What is the proof? I am going to give proof for this, but I can't do like this for every function. You will do it in mathematics. So later I'll just mention the formula. So proof is, you should find change in y by change in x. First you change x. Original value of x is x only. New value of x is x plus delta. So original value of y is sin x. New value is sin of x plus delta. Sin of x plus delta. So this is x values. These are y values. So what you have to do? Change in y. Change means final minus initial. So sin x plus delta, sin of x plus delta minus old value sin x by change in x, x plus delta minus x, that is change in x. If you simplify, it will be delta only, change in x. And that change in x or delta must go to 0. You have to calculate this. That is giving you dy by dx of the function y equal to sin x. Growth rate for y equal to sin x. So let's calculate this. So limit delta tends to 0, sin of x plus delta minus sin x by delta. And here you need some trigonometric relations. Sin a minus sin b, you will learn later, is 2 cos a plus b by 2 sin a minus b by 2. So this is there. There is also another important concept. When delta is very small, tending to 0, you can approximate sin of delta to be delta only. Sin 0 is 0, na? Sin 0 is 0. So if delta goes to 0, sin delta will be delta only. You can replace it with delta. Because whether you write sin 0 or whether you write 0, it is same. Sin 0 is 0 only. So using that concept, you can write sin of delta by 2. You can replace it with simply delta by 2. Because anyway delta is going to 0. Okay. So this relation will become limit delta tends to 0. 2 cos x plus delta by 2. 2 cos x plus delta by 2. Sin delta by 2 I am replacing with delta by 2 by delta. 2 cancels and delta cancels. And this value ultimately, when delta goes to 0, this value will go to cos x. When delta goes to 0, that value will go to cos x. So derivative of dy by dx, if y is sin x, dy by dx will be cos x. You also write like this, dy by dx, d by dx of what is y? Sin x. Instead of y, you can write sin x is cos x. You can write like this also. You can write like that. So I will give some standard derivatives or standard rate of change formulae. This you should remember, these formulae. Proofs for all these you will learn in mathematics later. I am not going to give you proofs. So first I will tell you some standard derivatives. So standard derivatives, which we will use in physics. Okay. So if y is x power n, first one which we already done, dy by dx, that is d by dx of what is y? X power n. This will be n into x power n minus 1. D by dx of sin x will be cos x. Okay. D by dx of cos x will turn out to be minus sin x. Why minus? You have to do the proof. I am not giving you the proofs. Then d by dx of tan x comes out to be secant square x. d by dx of cot x comes out to be minus cosecant square x. All these you have to remember. So when you're writing notes, please write them in your notes and remember later when you see the video. D by dx of secant x turns out to be secant x tan x. These all you have to mug up. Okay, d by dx of cosecant x is minus cosecant x cot x. If you see, derivative of all trigonometric functions starting with letter C, cot x starts with C, cosecant x starts with C, and cos x also starts with C. There is a negative sign in the answer. It's a good way to remember. Okay, there is a negative sign. Whenever there is a trigonometric function starting with C, cot, cosecant, cos, their derivatives will come with minus sign for some reason. Okay, it's a good way to remember. Then there is a number called irrational number called E, whose value is roughly 2.73 or something like that, but exact value is 1 plus 1 by 1 plus 1 by 1 into 2 plus 1 by 1 into 2 into 3 plus 1 by 1 into 2 into 3 into 4. This number is called E. Like this it keeps going, no end. Plus 1 by 1 into 2 into 3 into 4 into 5. Denominator is increasing, so it will become lesser and less. The terms value become lesser and less. But like this you should keep doing till infinity. That's why E is called irrational number. I think approximately its value to up to 3 decimal places is 2.718. Up to 3. If you want more decimal places, take more terms. So e power x is a very special function in physics also, in mathematics also. So d by dx of e power x, growth rate of e power x is e power x only. Very strange. So if suppose height of baby is changing as e power t, so height of the baby is changing as e power t, growth rate, speed with which height is changing is also e power t. That means if at some moment height is 10, speed with which head is moving is also 10. If at some moment height is 20, speed with which head is moving is also 20. So in mathematics we write like this: d by dx of e power x, growth rate of e power x is the same function, e power x only. Then we have d by dx of log x to the base e. Those who don't know logarithms, please my suggestion, please learn logarithms, quadratics, linear equations in 1 and 2 variables, even 3 variables, how to solve them. All these are important topics. This will be 1 by x. Okay, in mathematics you will be more precise. Instead of log x you write log mod x and so on. There are many stringent restrictions in mathematics. I am not going through all of them. So these are some of the important derivatives which we will use in our course: log x, e power x, sin x, cos x, cot x, tan x, cosecant x, secant x, and x power n, of course. Next class we will see rules on derivatives. This is the end of today's lecture. So we started with growth rate or rate of change. Okay, first we started with average growth rate, then we went into growth rate, then we came into all this. So try to see these videos again, write notes, try to understand things, not just mug up, understand also. Okay, that will help you in our further lectures. Okay, thank you.